So I have another example for section 3.7 that is about the position, velocity, and acceleration. So a particle moves according to f of t equals to cosine of pi t over 4. And let's say t is between 0 and 10. That we didn't go around for too many times. And part A, usually they're asking, the authors ask for the velocity. Part A, velocity. Well, velocity is the prime of the function. That's minus sine of pi t over 4 using chain rule times pi over 4. So that equals to minus pi over 4 sine of pi t over 4 is the velocity. Part B is asking velocity after 3 seconds. So f prime of 3 equals to minus pi over 4 sine of 3. Let me just put pi here. T was 3 divided by 4, just to be exactly the same as what I had before. So that equals to negative pi over 4. Sine of 3 pi over 4 is square root of 2 over 2. So this equals negative root 2 pi over 8. That almost equals to negative 0.56 feet per second. So the units for this problem are feet and second. I should have mentioned that in the beginning. Going to the next page, part C is asking, when is the particle at rest? C, when is the particle at rest? Okay, the particle is at rest when the velocity is 0. There is no velocity. So I'm going to go ahead and set that equal to 0, and now we are going to be using some trick. So minus pi over 4 sine of pi t over 4 equals to 0. If I divide both sides of this equation by negative pi over 4, this follows that sine of pi t over 4 equals to 0. And what does that mean? That means that so this is my theta, pi t over 4 is my theta. So pi t over 4 is 0 at pi and every multiple of pi. So I'm going to put here k pi, and I'm going to say k any integer. When k is 0, k could be 0, 1, negative 1, any of them. So now I'm going to have to solve for t. Multiplying both sides of this equation by 4 over pi, this gives me that t equals to, multiplying both sides of this equation. So the pi gets canceled out, so I have 4k, and we know that k, any integer. All right. Remember that we are looking for, when t, we are looking for the places between 0 and 10. When k is 0, let me go to the next page actually. When k equals 0, then t equals to 0, because 0 times anything is 0. When k equals to 1, then t equals to 4, because we had t equals 4k. When k equals to 2, then t equals to 8. And when k equals to 3, then t equals to 12. But this is not in our domain. So we have passed our domain. We are only looking between 0 and 10. So not in the domain. So at t equals 0, t equals 4, and t equals 8. So this is second. So those are the 3 times that the particle is at rest. Going to the next page. When is the particle moving in the positive direction? Part D. When is the particle moving in the positive and let's say negative direction? Well, if the sign of, if the sign of the velocity is positive, it's moving the positive direction. If the sign is negative, it's going the negative direction. So here's what we mean. We start from 0, and we said that we're going up to 10. And we said that the velocity was 0 at 4, somewhere here, and at 8, somewhere here. If I plug in a sign between 0, a number between 0 and 4, let's say 1, if I plug that into my velocity, which is negative pi over 4 sine of pi t over 4, that gives me a negative. So all numbers here give me negative sign. Every number in between here gives me positive, and everything else between 8 and 10 gives me negative numbers. Just choose any number, substitute it into the velocity, and and solve, or use your calculator. So for positive direction, we see that t has to be between 4 and 8. And for negative direction, t has to be between 0 and 10. No, what am I doing? For negative direction, t has to be between 0 and 4, and t has to be between 10 and 8. Okay. Going to the next page. The next thing that the author of this problem is asking is find the total distance during the first 8 seconds. The total distance during first 8 seconds. So look at this in here. Okay, I have for the first 8 seconds, the only turn that they have is right at 4. There's only one turn that the particle is going from negative direction to positive direction, because we are finding the distance. We are finding the distance for the first 8 seconds. So that's going to be absolute value, because this is distance, absolute value of f of 4 minus f of 0, and add that to f of 8 minus f of 4, absolute value. So this one, f of 4 is negative 1 minus f of 0 is positive 1 plus f of 8 happened to be positive 1 and minus f of 4 happened to be negative 1. So this part gives me negative 2, absolute value of that is 2, plus this also gives me positive 2, absolute value of that is 4. For what? 4 feet is the total distance traveled, not the displacement, the distance. Part F is kind of interesting. And the author is asking, give or draw some sort of diagram of the motion. Okay, we are just looking between 0 and 10. So if this is our position, let's say that 0 is in here. Let's say this is my position, S0 is in here. Let's say that negative 1 is here. Let's say that positive 1 is in here. So we have something like this. Yeah. So when t equals to 0, right here, we figured out, or if you plug in 0, you get the position as 1. All right. In here, this end point right here, when t equals to 4, s is going to be negative 1. And finally up here, when t equals to 10 and s equals to 0. So as you can see, the particle moved, but it did go back to where it started. Go back to where it started. So the total displacement in this case is 0 in the first 10 seconds. Part G is asking for acceleration at time t. So part G is asking for acceleration, which is the second derivative. I'm going to have f double prime of t equals to minus pi over 4. I'm going to keep it separate because it's a constant. Derivative of cosine is, derivative of sine is cosine. So I have cosine of pi t over 4. Using chain rule, I have pi over 4. And so that equals to negative pi. Let me change color. That gives me negative pi squared over 4 cosine of pi t over 4. And the unit for that is feet per second squared, or feet per second per second. And the author is asking acceleration. Okay, and let me put here after 3 seconds. So what is f double prime of 3? F double prime of 3 equals to minus pi squared over 4. Okay, so this goes minus pi squared 4 times 4. Here's a mistake right here. 4 times 4 is 16, not 4. You need to pay attention. 4 times 4 is 16. So this is minus pi squared over 16 cosine of, now instead of t, I'm going to put 3. So I have 3 pi over 4, and that equals to minus pi squared over 16 cosine of 3 pi over 4 is negative root 2 over 2. So that gives me negative times negative is positive, root 2 pi squared over 32. And that approximately equals to 0.44, 0.44 feet per second squared. So far, so good. Now, part H. This is a long problem. Part H is asking graph, position, velocity, acceleration in the same page. So all I say in here, there's no way I can do it in this iPad, so I'm going to say just use calculator. The next part, and really the interesting part, is that part I is, when is the particle speeding up? When is the particle speeding up, slowing down? We know that if the signs of velocity and acceleration, they are the same, they're both positive, then it is being pushed to the right direction. Or if they are both negative, it's being pushed the other direction. So if the signs are both the same, it is accelerating. If the signs are opposite of each other, then the particle is slowing down. So what's the easiest way of figuring that out is, let me go to this page. So let's put, first of all, let's have a diagram. I mean, let's put the acceleration set equal to 0, the second derivative. If I put minus pi squared over 16 cosine of pi t over 4, let's set that equal to 0. Divide both sides by the coefficient, and that gives you that cosine of pi t over 4 equals to 0. What does that mean? That means that pi t over 4 is 0. So it's going to happen at pi over 2, okay? So this equals to pi over 2 plus k pi, plus every k pi. K any integer, k any integer. So if I now multiply both sides of this equation by 4 over pi, I would get t equals to, I'm going to get, let me put it down here. Let me write down pi t over 4 equals to pi over 2 plus k pi. And I'm going to go ahead and multiply both sides of this equation by 4 over pi. On the left-hand side, I will get t equals to, the pi's cancel, so I have 2 plus 4k, k any integer. So when k is 0, then I get t equals to 2 seconds. When k is 1, then I get t equals to 6 seconds. When k is 2, I get 4 times 2 is 8. 8 plus 2 is 10 seconds. So, and at t equal to 10 seconds. So those are the places that acceleration equals to 0. So now let me go ahead and go to another page. For acceleration, I do have, here is, we said at, here is 2, at 6 it was 0, and at 10 was equal to 0. Plugging numbers in between 0 and 2 into the acceleration, I get negatives here, I get positives here, and I get negatives here again. So now, what did we have for velocity? For velocity, let me change color. For velocity, the critical points that I had was 4, which is right here, and the other critical was at 8, which is somewhere in here. Okay. And we said that between 0 to 4, everything was negative. Between 4 to 6, between 4 to 8, everything was positive. And after 8, everything was negative again. All right. So let's see, for now I can conclude that speeding up, speeding up is happening when the signs agree they're both the same. So speeding up is t between 0 and 2. Also t between 4 and 6. And t between 8 and 10. Slowing down. The signs are opposing. Where are the signs opposing? Look at here. Between 0 to 2, they agree. They opposed between, look at here, between 2 and 4. So I can say that slowing down, t between 2 and 4. And let's see here and here. So t between 6 and 8 seconds. I hope you enjoyed this video. I don't want to make it longer than this. Maybe, it's going to give me a problem uploading it. I'll talk to you later, and thank you.